Today we are going to do the binomial theorem in section 9.6, okay, on page 950, page 947, okay, and we're going to talk about the binomial theorem talks about how to multiply something like this out. Now we know how to multiply this thing if the power is, say, 2, okay, it's because x plus y squared, if the power is 2, is equal to x squared plus 2xy plus y squared. This is can be quickly done if you imagine multiply them each one by the other guy and by themselves. Okay, and so but the question is, what happens when there's 50 of them? Then you can look at it and say, well, I'm not doing 50 of those things, right? But there is actually a fairly quick formula to write that stuff out. And the formula is what we're going to learn today. Now, the first, to learn the formula, first we need to know what the coefficients are. That is, such as the coefficients are the numbers in front of the terms that we multiply out. And the binomial coefficient is given as it happened to be the same as the NCR that we learned in the previous section. Okay, that is now the binomial coefficient, we will write it like this, with a big parentheses on both sides, n on top and r on the bottom. And what that means is the combination, the NCR, which the book calls it CNR, same thing, okay, which equals to n factorial divided by r factorial and then n minus r factorial. The logic behind it is, I guess they're not going to talk too much about the logic behind it or why that is the case. So we'll just accept that as is, okay. So then that is so the first thing is the combination, the NCR or the CNR also is called the binomial coefficient, and you can write it as C of n comma r, like we did in the previous section, or you can write it like this. These two things mean exactly the same thing. So then, and remember, this thing can be punched out on the calculator. Okay, there's a specific button on scientific calculators that let you calculate this thing. That's because it's used so much. It's used both in counting the combination and also in the binomial theorem for the binomial expansion, which is often written like this. But it doesn't matter how you write it, it means the same thing. So let's look at example 1 on page 947, where we do a few calculations of NCR. That is the first one. So we'll pull out the calculator and do the calculations. Okay, so the first one is 5 choose 3. That's how you say it. Okay, the first one, I guess I'll write it down like this. N is 5. Okay, and then R is 3. So this is called 5 choose 3. The combination, and I will let's see. No, I'll do it on this side. So we'll do it like we did last time. We have to push in 5 and then shift. Where was NCR? I think is over my division symbol. So the C button shows up, and then 3, right? 5 choose 3 should be equal to 10, and yeah, that is correct. And then let's do part B. Well, actually, I'll let you do part B and C yourself. It's no different, okay? Just pull out your scientific calculator and do this kind of thing. It's just a matter of pushing 3 sets of buttons. The first number, then the C button, and then the second number, and then they all come out. So that's example 1. Next, we are going to look at the binomial theorem, which is on the following page, page 948. The binomial theorem looks very, very long, okay, and when it shows up. It says, here's the binomial theorem on the following page, x plus y to the power n equals the sum from 0 to n, and n choose k of x to the power n minus k and y to the power k. If you write this out, that means when k is 0, it's just x to the power n. Okay, because k is 0, then the y to the power k is just 1. And then you go down by 1. As k increases, the coefficient of the y's increase. See, y to the power 0, which is just 1, y to the power 1, y to the power 2, all the way up to y to the power n. Whereas the x coefficient decreases. We start with x to the power n, then x to the power n minus 1, x to the power n minus 2, and all the way go down to x to the power n and only 1, okay, and then eventually becomes 0. Now this formula might look a bit complicated looking, but in reality it is, we can look at some of the examples right under it. For example, let's look at the second one, x plus y squared, which multiplies out, as I've shown here, is x squared plus 2xy plus y squared. We're fairly familiar with that because we've done it quite a number of times. And then x plus y to the power 3 is x cubed plus 3xy squared, and so on. That is all represented in this formula. That is in the formula in the third power, then n will be equal to 3. Okay, so then you do n choose 1, which is 1. The first one is 1, okay? And then the second one, n choose 2, is 3 because you have 3. And so it has, the first one is just 1. I said that wrong. The first one is x to the power n. That's all. It's just 1. The second one is n choose 1, okay? So 3 choose 1, that is equal to 3. And then the third one is n choose 2, so 3 choose 2. And the last one is just y to the power n. And that is true to the x plus y to the power 4th as well. Now now notice how the coefficients of the x's go up and down. For example, the coefficient of x is start at x squared, okay, and then goes down to x, and then goes down to nothing. Whereas y starts at nothing, and then goes up to y, and then goes to y squared. The same way as here. See, in the fourth power, the x start at 4, and then go down to 3, 2, 1, and 0. And y start at 0, and then goes up to 1, 2, 3, 4. Now notice the total amount of powers, if you add them up, is always 4. That is x is power 4. Right here, x is power 3, y is power 1. The total is 4. Right here, x is power 2, y is power 2. Total is 4. So the total, as you notice, is all of the powers is always 4 in this case. And in the formula, you can see why. Because the total of the powers, if you add up just the power numbers, is n minus k plus k, which equals to n. So the total power for every term is always going to be equal to n, which is what the thing is being raised to start with. So every single term, as x decreases in power, y increases in power, their total, each term is still stay the same. But anyway, so we have this set of numbers, and there is anyway. So that is how this kind of stuff works. And there is of course the coefficients. That is these numbers that we see. For example, for the fourth one, okay, we have 1 and 1. Okay, 4, 6, 4, 1. Now those numbers when n equals to 4, okay, so n choose 0, that is 1, and then n choose 1 is 4, and when n is 4, that is 4 choose 1 is 4, 4 choose 2 is 6, and then 4 choose 3 is 4, and then 4 choose 4 is 1. So that is how that come out. Now let's look at the next page. Okay, we have something called the Pascal's triangle. Now the Pascal's triangle is a quick way of memorizing at least the first 5 things, which are mostly what we need to do most of the time. that is the triangle, this is how I memorized the binomial expansion. Okay, then that is we start with the first one that we already know. Okay, that is a square power. We just have 1 to 1. Okay, that's the first one, right? That is for the x the squared, the second power. Okay, which is 1 to 1 for the coefficients. Now the way I memorize this is, which is also shown in the book here. What you do is, what is the next row? The next row you just write a 1 outside, okay, and on both ends, and then you add up these things. 1 plus 2 is 3, and 2 plus 1 is 3. These things are always symmetrical left and right, so if you figure out that's 3, that's also 3 automatically. So the next row is 1, 3, 3, 1. As you can see in the previous example when we looked at x plus y to the power 3. As you can see, when x plus y is to the power 3, the coefficients are 1, 3, 3, 1. Okay? And then the next row is you do the same thing. You write a 1 outside on both ends, and then add up these things. 1 plus 3 is 4, okay? And then 3 plus 3 is 6, and then 3 plus 1 is 4. So the next row is 1, 4, 6, 4, 1. And I recommend that you simply memorize this. I just remembered these things. The first row is 1, 2, 1, then 1, 3, 3, 1, and then 1, 4, 6, 4, 1. And then the fifth row, then you continue doing this, okay? Let's see. Okay, now that's 1 plus 4 is 5. Let's see, I need to hold a pen right there. 5, 4 plus 6 is 10. And then the pattern repeats itself, okay, 10, 5, 1. So then the fifth row is 1, 5, 10, 10, 5, 1, which I also memorized. That's it. I think I memorized 5 rows because most of the time, any time we need this kind of stuff, that it just goes to 5 and no more, okay? I have all this. I can really say this in my sleep. Okay, it's one, like I can show you right now. It's 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. See, and yep, I got it right. So so I recommend that you memorize this thing as well. Not necessarily right now, but as time goes on, if you have to when you take more math classes and have to deal with this all the time, then each time you use it, try to memorize a little bit of it, and then eventually you get it all down, which is all I did. Okay, I didn't set out to memorize it; I just end up doing it. So that is those are the coefficients of the first 5 things. So as you can see here, x to the on the towards the middle or bottom or some page, that x to the power 5 is 1, 5, 10, 10, 5, 1, which means that the x to plus y to the power 5 is x to the power 5, okay? Then 5x 4y, see, as x go down in power, and then 1, 5, 10, 10, 5, 1, and then y increases by power 1 at a time until we got to the end where y is to the power 5th, and there's no more x. And that's how that comes out. So that is the binomial theorem, which if you write it in the formula form, will look like this. Okay, that is for any n. Now this formula looks kind of complicated, but it isn't. But it is only this thing. Okay, then you continue to, and the nk, when you have numbers instead of just symbols, you can just type it into the calculator, and then the number comes right out. So you start with x to the power n, then the power of n, power of x gradually decreases 1 at a time. Okay, the power of y gradually increases 1 at a time until you come to the end where you have only y to the power n, and the coefficient of y is 1. So because this thing always starts with 1 and end with 1, and you build a triangle and you can make it, well, let's not make it any more than 5, because there is no real point. Any more than that, then you just use your calculator and do the NCR thing on the C button on the calculator. Which I am surprised that your book doesn't seem to want to mention that. I mean, they like to mention using the calculator to do all kinds of other stuff, but you would think that NCR is the most important thing to mention. That is actually possible to do. So let's look at the following page, example 2. Okay, example 2, the first example, part A is book wants you to do x plus y to the power of 5. But let's not do that because it was done like just now. Where is it? Yeah, just on the previous page. It says so right here. See, on the previous page, x plus y to the power of 5. We just talked about it. So let's ignore that and do the next thing. 3x minus y to the power of 4. Okay, so that is more interesting. To the power of 4, then we are going to follow this formula right here, 14641. Okay, and then let's do that. So the 1 is 3x. Now this whole thing here now is the new x in the formula of the binomial expansion. So the entire 3x, so it will have coefficient 1, okay, to the power of 4. And then negative y will be the second term. That is, it will be this thing right here. So then to follow this formula, we have 1. Okay, we got 1 here. There's a 1 here, which I won't write down. And plus 4. And so this thing go down by 1 power. So 3x to the power 3, right? It started at 4, so go down to 3. And then the y value, which is now minus y, the value on this side, is it will pick up 1 power. So together they be the 1 power. So together they make 4 powers. Okay, and then 1, 4, 6, and the next one is 6. 6 times again 3x will be to the power 2 going down, whereas the negative y will be to the power 2 also. So it's still 2. And then next we'll have 1, 4, 6, then 4. Okay, the first term is 3x, and now the 3x is down to 1 power, whereas the y part, which is negative y in this case, is going to go up to the third power. And okay, 1, 4, 6, 4, and finally the last term, which is minus y, and just to the 4th power, and that's it. Because right now what we're doing is that the 3x minus y is 3x is the first term, okay, and then the minus y is the same as plus negative y, and that's the second term, and we're following the binomial expansion in that way. So now we have to do some more math. First, the first one is 3 to the power 4th. That's 9 squared, which is 81. So we have 81 to x to the power 4. This next one is 4 times something. That's 3 times 3 is 9. 9 times 3 is 27. So 27 times 4. And then there's a negative sign. So we'll write that here. And 27 times 4. Which is something, and then x cubed, okay, and then y. So let's figure out what 27 times 4 is real quick here. 27 times 4 should be 108. Well, it would be good if I turn on the calculator first. Try again. 27 times 4 is 108, all right. Let's see, all right, 108. And then the next thing we have, there's a negative sign, but that got squared. Yeah, watch it carefully. If it gets squared, it cancels itself out. So we don't have to think about it. This is 3 squared. That's 9. 9 times 6 is 54. So x squared, y squared. Next, this thing right here, we have a negative sign. That's to the 3rd power, so it's still there. So there's a negative sign. 3 times 4 is 12. And then x, and then y to the power 3. And finally, negative sign is raised to an even power, which means it disappears. And so we have the plus symbol, y to the power 4. And that should be the answer, as long as I didn't make a mistake. So let me check. Is this the answer to B? All right. So what is the answer of B? B says 81x to the power 4th minus 108x cubed y plus 54x squared y squared minus 12xy cubed plus y4. So I got it all correct. Awesome. So that is that. Now the next thing we're going to do is what if they want you to find the term for one of the terms? Okay, that is, you're not expected to expand the whole thing out, and you just need to find one specific term. Yeah. So to do that, then we follow this formula right here on this page. What page are we on? We're still on page 950, okay? So we need to find the specific term. It says right here in the formula, it says the r plus 1th term of the binomial expansion is n choose r, x to the power n minus r, y to the power r. Okay, that is just remember that that's slightly odd to say the r plus 1 term, but that's how things work out. So we're going to put that in mind. And now remembering that, let's do an example. Let's see, flip the page. Now let's look at example 3. Okay, we're doing x plus 2y to the power 16. But we're not going to expand that because that will take way too much writing. Instead, we're required to do the 10th term. Okay, the 10th term is, what is the 10th term? Let's go back to the formula where it says in the previous page, where it says the r plus 1th term is whatever, right? And so we need, what are we doing again? Let me see. It's x, the problem is x plus 2y to the power 16. Okay, this is the first term and this is the second term. So that the 2 is part of the second object that's being added. So then, so r plus 1 is equal to 10, so r equals to 9, and n equals to 16, and r equals to 9. Okay, then so that because they want the 10th term, that means r has to be 9, which by the given formula, as I copy it down here, will be equal to, where is my formula? Okay, it's equal to n choose 16 choose 9, and then x to the power n minus r, which is 7, okay, and then y to the power just r, power 9. So that should be it. And then what do we need to figure out what 16 choose 9 is? What's x7? Fine. Let's do that. Okay. Now 16 choose 9. Let's do that on the calculator. Let's see. We'll do 16 shift division sign. 16 choose what? 9. Okay, is 16 choose 9 is 11. Is that what the book says? Did I get something wrong? Oh, I'm so sorry. I forgot there's a 2 here. Okay, and that's what I said before. I missed it when I was doing the homework. So there's it's not just y to the power 9. It's 2y to the power 9. That's important. So then, and so what that means is the 16 choose 9, which is whatever I got here, has to be multiplied by 2 to the power 9, okay? Because both 2 and the y are being raised to the power 9. So that thing we will come back. So 16 choose 9 is fine. And then times 2 to the power 9, 2 to the power 9, okay? That is 585. Let's see, is that right? Let me check what the book says. Where is 5? What did I say it is? 585728. Yep, that is correct. Okay, so that is yeah. So be careful that when you write down the y, that don't just get carried away. Don't forget this. The 2y is together is the second term. So the whole thing has to be raised to the power 9 in the formula of finding the second term. Where's the formula? Here it is, okay? So here's the formula, but being that there's a 2y there instead of just y, then the entire 2 has to be stuffed in there, which means the entire 2 has to be raised to the power 9 as well, which totally changed the answer dramatically. So that is the end of our short little section. So for homework, on page 951, please do problems 7, 11, 15, 21, 25, 29, 39 and 47. And when you're done, I want to talk about some of them. And so right now, I will clean off the board. So now that you're done with the homework, let's talk about problem 21. We have one thing here, that's x to the power minus 1. and then the second object term is the 2y to the power minus 1. So we're going to expand this. It's the fourth power, and remember what the fourth power's numbers are? It's 1, 4, 6, 4, 1. The first number is always 1, and the second number is always whatever power this is, which is the n. Okay, in this case is 4. And I remember that the numbers here is 1, 4, 6, 4, 1, or you can just look it up in the book. And you can even follow the formula and calculate it, but that takes too long. Anyway, so to follow the pattern of 1, 4, 6, 4, 1, let's write this out. So the first one is x to the minus 1 is to the fourth power. Okay, everything always raises to the highest power here. And then plus, so the first term goes down by 1 power, becomes 3. The second term, 2y minus to the power minus 1, will increase by 1 power. So it went from 0 to the 1 power. And then plus, that's 1 and 4. Where's my 4? We'll write it down here. And then the third term is 6. And then the x has go down to 2, from 3 to 2. The y term goes from 1 to 2, and 2. And notice the total power stays at 4. Okay, this 3 plus 1, kind of there's a bit of a 1 there. So the total power stays at 2. I mean, stays at 4. Okay, they always equal to the same as this power right here. And then 1, 4, 6, and then keep going, plus 4. And x continue to go down. I mean, the first term continue to go down. This goes down to just 1 power. And this one goes up to 3, minus 1 to the power 3. 1, okay, so this is 1, 4, 6, 4, and the last one is 1, so which is the last object, which is the second term raised to the power of the whole power. So see, the first term and the last term both get to be on the fourth power, and they both get to be a third, and they both to be second. So it's very perfectly symmetrical and fair. Okay, nobody's getting ahead of the other. Now that we have that out, we just have to maybe do some cleaning up. That is, the first one is just is x to the power minus 4. It's minus 1 times 4. And the second one, there's a 4 here, there's a 2 here, so that makes it 8. 8 x to the power minus 3, y to the power minus 1. And then the third term with a 6 here, and then there's a 2 here that's being squared, so it's 4. 4 times 6 is 24. So we have a 24 x to the power minus 1 times 2, which is minus 2, y to the power minus 1 times 2, and also minus 2. And then, so that this is the equal sign. Okay, so this whole thing here equals right here. And so that is so the 2 and 2, and keep going. We have 4, sorry, I shouldn't write down the 4 yet, because we need to figure out if there are any more numbers to multiply. So we have a 4 here, but there's a 2 to the power 3, which is 8. So 8 times 4 is 24. So the total amount of numbers is 24. And then x is just to the power minus 1, and y is to the power, now minus 1 times 3 is minus 3. And then finally 2 to the power 4, okay, which is 16. And then y to the power minus 1 times 4 is minus 4. So that is it. That should be the right answer. Okay, so let me check. So I'm checking this thing. It says first one is x to the power minus 4, and then 8x minus 3, y minus 1, and then 24 x of minus 2, y minus 2. Now the answer have the negative coefficients under the division line. That's fine too. They're the same thing. You can write it either way. There's no real difference. And then next we have 20. That's the 24. The next x, and then it says 32. Did I get this wrong? I might have gotten this wrong. Let me see. Which one does this come from? X minus 1, right? Yeah. So 8 times 4. 8 times 4 is 32. What was I thinking? Anyway, so that's where it is. So because this is 8. 8 times 4 is 32, please. All right. So then, so that equals to 32, which makes it much better. Okay. Let's see. Yes. So that's 32. Okay. There's x to the minus 1, and y to the power minus 3, and then 16 times y to the negative 4. Okay, so all these things are actually under the denominator, and the negative power is just how you can write it without writing the division line. But anyway, so that is that for problem 21. So next, let's talk about problem 47, a quick little problem. We have x plus b is being raised to the 40th power, but what they want to know is what is the exponent of b in the kth term. So let's look at the formula, which is on page 950. Okay, it says the r plus 1 term is this thing, blah blah blah, x, the first term to n plus minus r, and the second term to the power r. So then the kth term then so would be equal to whatever x is, the exponent for b would be 1 less than r, the 1 less than k. That is, the exponent of b should be k minus 1, following this formula, okay? Because it will be 1 less than whatever kth term that we want. So that, yeah, so the answer should be k minus 1. And let me check to see if that's correct. 47. Yeah, it is correct. And that marks the end of this section.